Hi, Noah's detained, so I'm going to present my own work today. Hi, my name is Ben Feisch. Thanks very much for having me here today. I work at Johnson Space Center in the Ares division. And I'm here to talk about Apollo in real time, which you just heard a little bit about in the last talk, which was fantastic work. I just love seeing that work. Let me just advance the slide here. So Apollo in real time, I'm just going to quickly review it if people haven't seen it. It places back into context the mission data from first Apollo 17, which took a very long time, then Apollo 11 in 2019, and then Apollo 13 that was launched in time for that 50th anniversary in 2020. The general idea is to take all of the mission material that's first primary mission material, like transcripts, audio, video, everything from all the different disparate places that it has been stored and digitized, and bringing it all together into context. And basically it ties together all of this information that's usually in silos, like photo galleries that are always just photos and everything else. So that little animation that puts everything back into context took me 6 years working on and off on just Apollo 17. That work basically allows you to go back to any moment of the mission and actually witness what was going on. It's a living document that grows over time. For example, these entirely out-of-date lunar traverses that are in animations from LRO data can be updated and made better, which I'm very enthusiastic about the last talk, and I look forward to making these traverses less general. So this is an animation of their context at Station 4 where they were. And I just love the way that the data actually gives you this place, the sense of where this great human adventure was taking place. This is Station 8, and here's of course Station 9. You can see this little ribbon of dotted line that can now be updated to be better, just giving you an idea of the tremendous distance that the crew traveled. I will play this back, I think, without audio. So it works like this. This is the whole website. It's on one page, and at the top you get a timeline that's the entire 302-hour-long mission, in this case for Apollo 17, and 2 levels of zoom that let you use your mouse to get to any moment of the mission. The transcript is in the bottom left, which took a huge amount of work to get snapped into mission time. And then any video and animations that are available are in the video on the top left, and the Hasselblad imagery is on the right. And you can go back and play this. In this case, here's a clip of them raising the flag. And if you let this continue to play, it will play in this case for another 7 days until they splash down and are recovered by the USS Ticonderoga. Some people have actually watched the whole thing. It's kind of amazing. So it's also a tool. Here's an example of it being used as a tool where you type in a sample number, and it'll take you to the moment that sample was collected, and you can pause time and pivot around this moment. And you can get a link here, in this case, to the curation website, where all the research that's been done on this sample, including the sample compendium, are readily available. Every image that's been taken of this sample since it's been studied, and every academic paper that's ever been written that references to this sample is all located in context at the moment that sample was picked up. I look forward to seeing all the papers that we're hearing about this week as they get published being placed into context where the samples were being collected. Here, this does have audio. I'll play it in a second, but I just wanted to show how the different mediums being pulled together really help to be greater than the individual parts. So I'm going to play this. Hopefully we get audio. Nope, we get no audio. Okay, I'm not going to try to do a Jack Schmidt imitation. Essentially, they're on a traverse here on the way to Station 4 from Station 3. Jack's driving past this boulder and he's saying, hey, this is reminding me of something that I saw on the other side of the valley. And it has a similar vesicle size. And he's basically giving visual observations on this rock as they drive past. So you can see the LRO data giving you an idea of how fast they're moving, generally where they are. And then as the photographs are taken, they're appearing on the right. It's okay. Sorry, next slide is good. I should move on. That's okay. Yeah, so that's basically Apollo in real time. And thought this is really where I wanted to be able to tell you that this work was done, but this work isn't done. So 30-track historical tapes. This is a very important addition. So these tracks, these tapes were recorded in mission control throughout all of the Apollo missions, and each of them contains 30 tracks of audio. There's 2 concurrent recorders recording everything that's said in mission control for a total on Apollo 17 of 23,000 hours of audio. They look like this. Here's a picture of one of them. In this case, this is an Apollo 13 tape. This is in fact the Apollo 13 tape that was being recorded when the explosion occurred on board. It was amazing to hold that in my hand as we digitized it. So here's an example of the 2 tapes. This is Apollo 11 again, where you can see all the different people in mission control, all wearing headsets. That was all being recorded onto these very slow tapes. And it was used for investigation purposes. It was used like it was used on Apollo 13 for the congressional investigation into what occurred and whether or not there was any kind of mistakes that needed to be remedied within mission control. And of course, they, instead of finding any mistakes, all received the Presidential Medal of Freedom for their work. And this has all been digitized for Apollo 13 and 11. And all of this material, here's the actual machine in Building 2 at JSC, the last remaining machine in the world that can play these tapes. And all the tapes are in College Park, Maryland at the National Archives. So there's a major effort being done right now to digitize the remaining set of tapes. And I think if this is the right version of the presentation, yeah, so with the help of the Historical Preservation Officer at Johnson Space Center, Sandra Tetley, this hardware was purchased in order to digitize these tapes 30 tracks at a time. This machine was only ever meant to play 1 track at a time. So a group at UT Dallas retrofitted it with a 30-track playhead. There's a whole thing that happened to try to get this to work. But essentially this puts this material into this left side of the screen here, where you get all 30 tracks of a tape. There was I'll just briefly say, there was a lot of work that had to be done by some people that have been helping me with Apollo in real time to write algorithms that would take the time code on track 1. So this is key. Time, as you can see, is an obsessive thing now when you're making Apollo in real time. There's historical time code that has Greenwich Mean Time on these tapes on track 1. And using that signal and the actual essence of that signal, these tapes were retimed to be like they were digital tapes, removing any warbling or issues and retiming them exactly to mission time. So now we know it's the only primary source we have for actual sequence of events during the Apollo missions. And you can place everything like collage on top of these tapes once you digitize them. Here it is for Apollo 11. After that's all been processed and put into Apollo in real time, you can open this mission control audio panel, and you can sit in any position in mission control for the entire 270-hour-long Apollo 11 mission and be the flight dynamics officer if that's what you always wanted to be. And there's a huge amount of work that can be done to study the efforts of the people in mission control in this case. So right after Apollo 13 was launched in April 2020, and you all remember what was happening in April 2020, so there wasn't a lot of attention paid to the work that was done for the launch of Apollo 13 in real time. I got a message from the head of the National Archive Film and Audio Division, who said he had found the Apollo 17 30-track tapes in the collection and sent me these tantalizing images of just historical recorder 1. I don't even know what's on historical recorder 2, but you can see on the top right, there's the LSEP network control position. That's a new position since Apollo 13, and gives indication that there could be audio that shows the people that were in the geology back room throughout the whole mission. And you can see the headset that Jim Lovell is wearing. He was the head of the back room. that he's going to be telling, we have some footage of the people doing their work here on the left in the back room, but any decision they made had to go through Jim to get to the front room. And that will, for the first time, be put back into context for the entire Apollo 17 mission. We'll get to see how the science decisions were made and supported through all the science operations. So that's on its way, and I wish I could say it was like live today. That's what I really wanted to say, but it's not. Because the National Archives has actually had to shut down since about May of 2020 and has such a huge backlog now that we can't get the tapes to digitize them. And I even threatened to fly down there, and they said, well, if you fly down here, we can have a beer, but you still aren't going to have the tapes. So they're on their way. It'll happen. So how do you use this information, this mode of operation? So everybody shut down for the pandemic, and being a software engineer, it was, okay, I have no material for Apollo in real time. I now work at Johnson Space Center in the Ares division. What is a good pandemic project? So the first pandemic project was Astro Materials 3D, led by Erica Blumenfeld. I don't know if people have seen that, but I built that. And then it was time to make basically this, which is ISS and Neutral Buoyancy Lab and all the field test events in real time for NASA. So CODA is a lot bigger than Apollo in real time. It takes a lot more types of information and places it all into context. And it does it in an automated fashion, so it doesn't take a crazy person like me to actually reassemble it. And it looks like this, very similar. I kind of a little homage to Apollo in real time with the timeline at the bottom there, like with all the different media in it. And you can go to any day on the ISS since 2013, at any moment of any day, and hear what they were saying and what they were talking about, and actually see all the different 6 to 8 downlinks of video, etc. Okay. And this is all an internal NASA system, because of course none of this material is gone through export control. It's not, we want it to be operationally available tool, not a publicly available tool yet. I want to show you how this works. Okay, this isn't actually I actually don't need audio for this one. This is good. So I'm playing forward, and you can see there's a AI generated transcript in the center. And this is a moment when a bolt flew away during an onboard EVA. This is the kind of event that requires a huge amount of investigation to figure out what direction did the bolt go, what velocity did it leave at, any remedies that need to be made. Basically, it's when mission control snaps into action to try to understand the event. And here they can roll back time and go back into context and actually look at a different camera feed and watch that bolt fly away. Now you still can't see the washer and the bolt. So I'm going to zoom in here and you see if you can watch it fly away. Did you see that? Okay, one more time, this time with a circle around it. So that's the kind of needle in a haystack that everybody's looking for. And this is the kind of stuff that we're going to be obsessing over during Artemis. And all the science work that's being done, all the data that's being gathered for Artemis will all also, if I have my way, be pulled into context as it's brought down so that it doesn't have to be reassembled. Similar to this, in that it just happens by itself. So having CODA in operations is we actually asked people for testimonials, and we got about 15 or 20 of them. People are, the reaction is, why didn't we have this already? And whenever you hear as a software engineer, why didn't this exist already? You're in the right business. And there's a good history as for why it didn't exist already. But NASA's been collecting its data very carefully for all this time, and it can only be reassembled this way because they've been so careful in how they've been collecting their data. But having a tool like this now, not just desired or a nice to have, but being seen as something that has to happen, means that it's being recognized. So this is an award the project got. Our little team each got one of these for the work that we're done. It's being recognized as like a good thing happening, and it's let's just say it's culturally within the culture of NASA. Assume that it's going to be there for NASA. Sorry, for Artemis. And if it's assumed to be there, then it will be there. And that's, instead of having to convince anybody that we should be allowed to make it for Artemis, we're just going to satisfy their desire and have it available as the opportunity permits. So with that, I think I'll leave it there, but happy to answer questions when it's question time.
Great. It's question time now. Thank you, Ben.